Maintenance of experimental magnet motors and free energy rigs. Experimenting with magnet motors and free energy rigs is one of the most exciting frontiers of independent research. These devices represent the possibility of tapping into natural forces, magnetism, resonance, and gravity, to create motion and power without traditional fuel or electricity. Yet, like any machine, they do not simply run forever without attention. Maintenance is a critical part of ensuring that these rigs operate smoothly, safely, and reliably. Today, we will explore in detail how to maintain experimental magnet motors and free energy rigs. From cleaning and lubrication to alignment, from magnet care to structural reinforcement, this guide will cover everything an experimenter needs to keep their devices in top condition. Why maintenance matters. The concept of free energy often inspires the idea of endless motion without input. While magnets and resonance can indeed sustain cycles, the physical reality of bearings, shafts, coils, and housings introduces wear and tear. Dust accumulates, friction increases, magnets lose alignment, and wires degrade. Without maintenance, even the most promising prototype can fail or give inaccurate results. Maintenance is not about limiting the dream of free energy. It is about protecting it. By taking care of the rig, you extend its lifespan, ensure accurate testing, and prevent avoidable failures. A well-maintained device is a reliable teacher, while a neglected one is only a source of confusion. Cleaning and dust management. Dust and debris are silent enemies of magnet motors. They collect around bearings, in coil gaps, and on magnets themselves. Over time, they increase friction, reduce efficiency, and even interfere with resonance. The best practice is to clean the rig regularly using soft brushes, compressed air, or microfiber cloths. Avoid harsh chemicals, as some can corrode magnets or insulation on wires. For outdoor rigs, dust filters or protective enclosures reduce exposure. Keeping the environment clean is as important as cleaning the rig itself. A useful habit is to schedule cleaning after every extended run session. This ensures that small deposits are removed before they accumulate into problems. Lubrication of moving parts. Friction is the greatest opponent of perpetual motion. While the aim of magnet motors is to reduce or eliminate external energy input, physical contact surfaces always generate resistance. Bearings, shafts, and gears must be lubricated carefully. Choose lubricants that match the scale of your rig. For small tabletop prototypes, light machine oil is sufficient. For larger rigs, grease designed for high-load bearings may be better. Apply sparingly. Excess oil attracts dust, which then accelerates wear. Check for signs of dryness or noise during operation. A well-lubricated motor should run quietly and smoothly. Squeaking, grinding, or vibration are early warnings of lubrication failure. Alignment of components. Magnets must be positioned with extreme precision. Even a small misalignment can create drag, stall motion, or reduce efficiency. Over time, vibration or thermal expansion can shift magnets, coils, or structural parts. To maintain alignment, check the positions of all magnets regularly. Use calipers, rulers, or laser guides to verify distances. Secure magnets with strong adhesives or mechanical clamps to prevent drifting. For rotating assemblies, balance is crucial. Imbalanced rotors cause wobble, which leads to uneven wear and energy loss. If misalignment is detected, adjust slowly and carefully. Never force magnets into place, as they can snap together dangerously. Instead, use non-magnetic tools and protective spacers during adjustments. Care for magnets. Permanent magnets are powerful, but they are not indestructible. Overheating, mechanical shock, or corrosion can weaken them. Neodymium magnets, for example, lose strength quickly at high temperatures. To protect magnets, avoid operating rigs in hot environments. Keep them free from moisture to prevent rust, and consider coating exposed surfaces with protective sprays or epoxy. Handle them gently. Dropping or slamming magnets together can chip or crack them. When not in use, store magnets properly. Keep them away from electronics, credit cards, and sensitive instruments. Stack them with spacers to avoid sudden snapping together. Treat magnets as both tools and treasures. They are the heart of the system. Electrical connections and wiring. Free energy rigs often include coils, capacitors, or feedback circuits. Over time, wires loosen, insulation cracks, and connections corrode. Poor wiring creates resistance, sparks, or intermittent failures that are hard to trace. Inspect wiring regularly. Look for discoloration, fraying, or loose terminals. Replace damaged wires immediately. Use heat shrink tubing or insulating tape to protect connections. Solder joints should be shiny and solid, not dull or brittle. For outdoor rigs, use waterproof connectors and conduits. Protect circuits from rain and humidity. Moisture is one of the quickest ways to ruin an experimental system. Bearings and shafts bearings carry the load of spinning rotors. If they fail, the entire system can collapse. Over time, bearings wear down, producing noise, wobble, or resistance. Shafts may bend under stress, misaligning the rotor. Check bearings by spinning the rotor manually. It should turn freely without grinding or resistance. If it feels rough, replace the bearings immediately. Modern ceramic bearings are durable and efficient, though more expensive than steel ones. Shafts should be inspected for straightness. Even slight bends create imbalance. If a shaft is damaged, replace it rather than attempting to straighten it, since weakened metal may fail under load. Structural integrity: frames, mounts, and housings must remain solid. Vibration and repeated stress loosen screws, crack joints, or bend supports. Over time, the structure itself can degrade, leading to misalignment or collapse. Inspect the frame regularly for cracks, loose bolts, or warping. Reinforce weak points with brackets or additional supports. If working with wood, check for splitting or swelling. For metal frames, check welds and joints for fatigue. A rigid structure ensures that the delicate balance of magnets and coils remains stable. Without structural integrity, even the best design cannot perform well. Monitoring performance maintenance is not only about physical care. It is also about observation. Keep track of how the rig performs over time. Record rotor speed, noise levels, temperature, and output. Any change in these readings may indicate maintenance needs. A sudden drop in performance often points to dust, friction, or misalignment. Rising temperatures suggest lubrication or electrical issues. Keeping a log helps you identify patterns and prevent failures before they occur. Preventing corrosion: many free energy rigs are tested outdoors, where they face rain, humidity, and temperature swings. Metal parts corrode quickly without protection. Rust increases friction, weakens structures, and damages electrical paths. To prevent corrosion, coat metal parts with rust inhibitors or protective paint. Stainless steel and aluminum resist corrosion better than regular steel. Keep rigs covered when not in use. Magnets themselves are vulnerable, especially neodymium, which corrodes easily. Use nickel-coated or epoxy-coated magnets when possible, and inspect them frequently for damage. Safety considerations: maintenance also means safety. Magnet motors can spin at high speeds, and magnets can snap together with dangerous force. Always wear safety glasses and gloves during adjustments. Disconnect any power sources before handling circuits. Keep flammable materials away from the rig. Ensure that the work area is clean and free of clutter, so that tools and parts do not interfere with operation. Never push a rig beyond safe limits just to test Overunity claims. A destroyed prototype teaches nothing. A carefully maintained one continues to inspire discovery. Long-term care: think of your free energy rigs as long-term companions. They are not disposable gadgets, they are evolving experiments. Regular maintenance, cleaning, lubrication, alignment inspection ensures that they remain functional for years. Store them properly when not in use. Keep them covered, dry, and protected from accidental damage. Label parts and keep spare components handy. Treat every prototype as a step in a larger journey, one that builds toward more powerful and reliable systems. The joy of maintenance: some may see maintenance as tedious, but for experimenters, it is part of the adventure. Every inspection teaches you more about how your rig behaves. Every adjustment brings you closer to understanding the delicate balance of forces at work. Maintenance transforms frustration into progress because it turns problems into learning opportunities. Let me ask you something engaging. Would you rather spend days building a rig only to see it fail after one session? Or would you rather have a rig that runs for years, teaching you new lessons every time you switch it on? The answer is obvious. Maintenance is not just duty, it is pride in your creation. Clean your rig regularly. Lubricate moving parts. Align magnets with precision. Protect and handle magnets wisely. Inspect wiring, bearings, shafts, and structures. Monitor performance, prevent corrosion, and above all, stay safe. Every act of maintenance is an act of respect for your work. It is an investment in the future of free energy experimentation. With each rotation of a well-maintained rotor, with each hum of a clean coil, you are not only testing a machine, you are nurturing the dream of energy independence. That is why maintenance matters. It keeps the dream alive, not just for today, but for the years to come.